They have made math another language, so you can't understand simple things, so they can hide it from you. But I'm going to speak plainly to you. He who has ears to hear, let them hear. Dividing the 1-inch diameter circle 360 degrees is equal to dividing the equilateral triangle from a 360 hypotenuse. Degrees are originally lengths from the 3.6-inch ball. The ball is made up of many circles. The triangle sides are diameters of those many circles. So understand whenever I say 90-degree hypotenuse diameter, 60-degree opposite diameter, 30-degree adjacent diameter. Now let's get some visual on what I'm speaking of. Inside of the 1-inch diameter circle, the 60-degree right triangle opposite side is the 60-degree portion of the circle, and its length is equal to the square root of 0.75, 0.866025438. This is a replica of the 3.6-inch circumference circle. The diameter is equal to the square root of 4/3. The adjacent side is 1 inch. That is where inside of the ball the 1-inch diameter circle is. He who has eyes to see, let him see. We're going to bring to life these three diameters. The square root of 4/3, the square root of 1/3, and the square root of 1. First, I want you to know that every right triangle, this is a 30, 60, 90 right triangle, on its hypotenuse has two arcs that perfectly sit on top of it that add up to equal 180 degrees. The degrees double from inside to outside, so this 30-degree angle reflects 60 degrees, and this 60-degree angle reflects 120 degrees. Now keep in mind the 60-degree portion, the adjacent, creates the equilateral triangle inside of the circle. This is the 1-inch diameter, so this is this portion right here, and this distance is the same distance from here to the top of the 90-degree diameter circle. So God placed the 1-inch diameter circle inside the 3.6-inch ball perfectly where the 60-degree portion of the 1-inch diameter circle equaled the equilateral triangle height. So the square root of 3/4 reciprocates the square root of 4/3. So the equilateral triangle height reciprocates the diameter. So whenever you multiply the equilateral triangle height by the diameter, it will equal the equilateral triangle length square. That's why dividing the circle is the same as dividing the equilateral triangle.